So we have done with the basic question here. Now I am going back to a raised to x by b remainder equal to r. Now using this, so we have already solved two questions based on this, right? Where a was 2 and this was 32, this was 17 and 15 and all, and we got the answer as 1. We got the answer as +1 in both the questions. Now, how is it useful in divisibility rules if you ask me? That's one of its important applications. Unconventional but very easy to understand and use. So, if you want to learn divisibility rules, or if you want to know divisibility rules, see, in our in base system 10, we use numbers from, what are the numbers which we use? Numbers used are 0, 1, 2, 3, 4 up to 9, right? We use numbers from, these are the numbers used. Now in base 10, if you want to find divisibility rules, what you are supposed to do is, see, a raised to x by b equal to r, remainder r, that's why I am writing r here. So to find out divisibility rules, replace a by 10. Replace a by 10. Now why 10? If you ask me, 10 because we are dealing with base 10. Now, for whatever be the number where you want to find the divisibility rules, I'll start with some basic numbers because we know the we have memorized the divisibility rule for 3. What is the divisibility rule for 3? Sum of the digits. Now, why we use sum of the digits? If you want an answer, this is the best method to answer, and only then you can use it in indirect questions. So, to find the divisibility rules for, let's say, 9, I need to write the divisor as 9. So 10 raised to x by 9. What are the possible values which r can take? Possible values. Because why I am asking possible values? Because I have not fixed any number here. If I fix a number here, then you will get a single answer. So 10 raised to x by 9, what are the possible remainders? So I'll just start verifying this. Now I've kept it as x here. I'll start with the first value. 10 raised to 1 by 9. What is the remainder? +1. Now 10 square by 9. What's the remainder? +1. 10 cube by 9. What's the remainder? +1. So now we have a very basic divisibility rule because of this reason. That is, see, I can express this in words. 10 raised to x means, how will I write? Any power of 10. That is why I am keeping it as x. Any power of 10 divided by 9, remainder is fixed at 1. This is why how we can use it in divisibility rules is very simple. That's why if you have a 2-digit number, let's say a 2-digit number AB, a 2-digit number AB can be written as 10A plus B, right? Or a 3-digit number ABC can be written as, how will you write? Using powers of 10, 10 square A plus 10 raised to 1 B plus 10 raised to 0 C. Now if you take, what we are using is nothing but basic remainder theorem. You need to understand that. You divide this by 9. When you divide this number by 9, what are the individual remainders? 1 by 9 remainder is 1 itself. 10 by 9 remainder is also 1. 100 by 9 remainder is also 1. So what are the individual remainders? It's +1 everywhere. That's why you can neglect that, right? Now apply basic remainder theorem. This is how we'll apply, right? This ABC, when you have this number, this is your number, ABC. Now I am applying basic remainder theorem, +1 into C, +1 into B, +1 into A. So indirectly I can just take AB, A plus B plus C. Now, so what is the divisibility rule? Divisibility rule is, to find the divisibility rule for 9, for a 3-digit number ABC, rule is very simple. Take A plus B plus C. Now write this in words. If you write this in words, you will write it as sum of the digits. So rather than just memorizing sum of the digits, if you understand this way, this is the same thing which will extend it for other numbers also. That's why it's important. It's not important in terms of, because you can still memorize sum of the digits. You will still be able to solve direct remainder questions or direct divisibility questions. But you are not preparing to solve divisibility questions in CAT. That's not the only thing which you are preparing for. So knowing is what matters. So this one, so why do we use sum of the digits? You have an answer now. Why do we use sum of the digits? Because now even if it's a 4-digit number, A, B, C, D, what will happen is, a 4-digit number using, you can expand and write this as 10 cube A plus 10 square B plus 10 raised to 1 C. I'm writing 10 raised to 0 D so that you can get the pattern. Now if I am using 9 here, this will explain divisibility rule for 9. What are we using here? We are still using basic remainder theorem because we have already factorized the numerator and then we are again taking it as sum of those numbers. What are the individual remainders? Plus 1, plus 1, plus 1 and plus 1. Now why it's plus 1 everywhere? Simple answer. Any power of 10 divided by 9 remainder is 1. So when you get the final answer, your final answer will depend on plus 1 into D, plus 1 into C, plus 1 into B and plus 1 into A. Because these are the individual remainders. In turn can be written as just A plus B plus C plus D. It can be written as A plus B plus C plus D. Now when you write it as a rule, it's nothing but sum of the given digits. So sum of the digits. Now this is why the same reason we use the rule for 3 also. Because I can just replace 9 by 3. Nothing else will change. Any power of 10 divided by 3 also, individual remainder is, what is individual remainder? What is 1 by 3 remainder? 1 by 3 remainder is 1. 10 by 3 remainder is 1. 100 by 3 remainder is 1. 1000 by 3 remainder is 1. So that's why for 3 and 9 we use the same rule. What is the rule? Sum of the digits. That I am sure all of you know. Sum of the digits. But why do we use sum of the digits? You know that. Why do we use sum of the digits? Because any power of 10 divided by 3 or 9 will leave a remainder of plus 1. Any power of 10. That's why in our expression, I can simply write it as 10 raised to x. This is any power of 10. Why I am explaining this way is because when you read sentences, you need to write variables or the other way around. Any power of 10 divided by 9 remainder is plus 1. So this is the reason. Plus 1 is the reason why we use that rule. Now it can be 3 also. Divisor can be 3 also. Rule won't change. So 3 and 9 rule is over. Now we will extend the same thing to, now I will try writing some other number here, 11. If I write 11 here, this is not correct because it's not always plus 1. It's not always plus 1. So what will happen is, now start writing values for x. First you start with 0 itself. 10 raised to 0 by 11, remainder is plus 1. That's correct. Then substitute 1. 10 raised to 1 by 11, what's the remainder? 10 or minus 1. 10 by 11, what's the remainder? 10 or minus 1, right? 10 or minus 1. So I am writing minus 1 here. Now 10 square by 11, what's the remainder? That's plus 1. 10 cube by 11 remainder will be minus 1. 10 raised to 4 is plus 1, minus 1, plus 1, minus 1, like that it will continue. So that's why we can make a rule based on plus 1 and minus 1. So our rule will depend on, the only change here is, if you ask me, the only change is, see I am replacing 3 and 9 by 11 now, so that we will get divisibility rule for 11. Now, if I replace 9 by 11, what is the difference? First it's plus 1, because 1 by any number is plus 1, but here it's minus 1. And here it is plus 1. Here it is minus 1. So there's some difference here. So to simplify this rule, what we normally do is, we take all, see when you are assigning individual remainders, this is correct, plus 1. Rightmost is always plus 1. But this will be minus 1. This is plus 1. This will be minus 1. So as a rule, it's very easy. What you need to do is, you take all plus 1s together and subtract, take all minus 1s together and take the difference. So it's like this, right? You'll take, what will be the rule? B and D you will take together because they are with plus signs. So I'll write it as B plus D because they are with plus signs. Now take all these two together, A and C, minus of A plus C. That's the rule. So when you write it as a rule, it's very simple. You write it as sum of the digits at odd places minus sum of the digits at even places. That's how you must have learned. Divisibility rule for 11 is when you write this in words, sum of digits at odd places, odd place starts from the rightmost. Sum of the digits at odd places minus sum of the digits at even places. Now why we do this? Sum of the digits at odd places. We do this because digits at odd places will carry a +1 sign, all of them. And digits at even places will carry a -1 sign. So in short, it's just that you just need to take difference between digits at odd and even places. Not odd numbers, odd and even places. You'll get the answer. That's the divisibility rule for 11. But what you need to understand is all of them are actually based on basic remainder theorem. The reason why you can use this rule is basic remainder theorem. That is the idea, more than just learning this 3, 9, 11 and all. So this will help you to find out divisibility rules for numbers even if you are not familiar with it, as and when it's required. Because you can see in papers, you can see divisibility questions based on 74 and all. Or even 66, there are previous questions. See, when you have 74 and all, or 37, because 74 is based on 37 and 2. 2 divisibility rule is easy. 37 you'll have to find the divisibility rule. So, in some of the moderate to difficult questions. So here, see right now I'm explaining divisibility rules. I'm explaining divisibility rules based on basic remainder theorems.